Alright everybody, let's go ahead and get started today. Okay, we'll do one last day of doing the global game, but then after this there's some other games that I think would be fun to play. And maybe this one is maybe getting more repetitive for us. But let's try to get this one in 5 guesses, okay? Last time we got 7 and we did it on the 7th guess. So let's try to get 5 this time. Could someone, maybe that doesn't participate so much in this game, want to just shout out a country? Anybody? Yeah. Iraq. That's great. That's great. Is this an AI violation or was this legit?
I don't know. I have never played this game.
Oh my god. Okay. Alright. That was like either insanely lucky or someone just played this game before the lecture. But maybe this is why we also need to switch games. But now since they only release like 1 per day, like the chances are we can't even like play a different country or something. So alright, good job everyone. We beat the game. Okay, let's start with some announcements. So Project 1 was due last Friday, technically on Thursday, but you had until Friday night to turn it in. We're gonna do grading this week. Our goal is to have like a code review for you done by Friday. And the way the grading is gonna work in this class is that you'll submit your pull request. We're gonna do a code review, okay? So we're gonna have the tutors and me reviewing everybody's code, and what we'll likely do is leave comments for changes that you need to make, okay? We'll be like, oh, can you just clarify this detail, or can you expand on the what I learned section? And then you'll have about 3 days, depending on the day that you get the feedback. Like if you get the feedback on Friday, you don't have to submit it by Monday. We'll probably give you an extra couple days. But you'll make that change, and then we'll regrade it basically. So the goal is that if there's any things that you didn't do very well in the pull request, you have a chance to make those points back up. But it's also meant to function as like how actual code reviews work in industry. So Project 1, you're just building a development environment, but in Project 2, which I'll be talking about today and which will be released after class, you'll be making actual code changes, and you'll have to include like a design document, you'll have to include a process journal. These are things I'll also talk about today. But for those you want to, you'll probably have to like make actual changes to the code that you had initially submitted, or changes to the design document, okay? That's kind of how actual code review works. It'll very rarely will your initial changes be just accepted. There will be maybe some code style issues that you'll have to fix, some code quality issues you might have to fix, which we discussed last week. But again, remember the goal of this, it's not for us to be more like punitive in the grading. We're not going to be super harsh with like, oh, you didn't, have the best code quality. That's going to be like minus 10% of your grade. That's not the goal of this class. The goal is that you take the feedback and are able to make the change that sort of uses that feedback, okay? And as long as you're able to address the feedback and improve in that second submission, then your grade will be fine, okay? Are there any questions just about how the grading is going to work for this class or this process of the code review? Okay, cool. I think if there's anybody that still has issues with setting up a workspace, like if you got in off the wait list and are even like unsure what I'm talking about right now, like building a development environment, just come up to me, Charles, or Cushy after class. Just come after class and we'll just maybe hear out whatever situation you're in and figure out a fix for it, okay? Okay, in other news, Project 2 is going to be released today. Project 2, you're going to be like upgrading one of the features that exists in idlib. I have an alarm on my phone for 4:43 to just make sure that whatever we're currently talking about when we get to that time, we'll just start going over Project 2, because I'll give some like helpful context and sort of motivate the project in the last like 7 minutes of lecture today. Third, there's a reflection survey, okay? So this is going to be required for everyone to do. It's actually in the second to last slide. You can do this after class today. Definitely don't do it in class. There's, a few open-ended responses. And it's also anonymous, okay? So you can write whatever and we're not going to know who said it. So don't maybe have like hate speech in there, just the reason it's anonymous is for y'all to be honest with the feedback, okay? Like as you know, this is sort of like this is the second time this class is being offered. It's the first time that I'm teaching this class. So the feedback that y'all give, it's actually going to impact what we do like next lecture or next week or for the rest of the class. So just please be honest with whatever is working well in the class and also things that are not working well, all right? So the way this is going to work though is that after you submit this reflection survey, the like confirmation message is just going to have a little like passphrase or something. It'll just say like the passphrase is something in quotes, okay? Just to like confirm that you've done it, you'll just have to copy that like password into this exploration activity, okay? This is going to be something that you do after class. Again, I mentioned this I think in the first lecture of this semester or of the quarter, which was we'll just have like 2 or 3 of these throughout the quarter. It's pretty informal. It's not going to be graded on correctness, but you'll just have to use the debugger to sort of explore some part of the code base, okay? And I realized here I just need to put in what is the password from the reflection survey. And this will be required as part of the exploration activity. Let's call it exploration activity 1. Okay. But again, this is meant to be done after class. The exploration activity, you'll have a few days to do it. Again, we're pretty flexible on this, somewhat informal. The goal is just for you to actually experiment with the code navigation, code comprehension techniques that we use in class. Lastly, I want to just make a reminder about the STEPIC textbook. I haven't done a great job about publicizing this quarter so far, but this is sort of a new textbook that we created to supplement this class. And right now, you can see right now the public-facing versions of them will be things that we've gone over in class. So I think the code navigation section, like if you miss stuff in lecture or are still confused about stuff in lecture, there's some pretty helpful pieces of information up on this about like reviewing code navigation techniques, about making experimental code changes, about using the debugger, which we'll be going over today in class. So feel free to visit this STEPIC textbook. There's also, I'll point out, like videos for all of these about like more demos and examples of how to use these code comprehension techniques. So if there's something that you felt you didn't pick up well during the lecture, well, first you can actually watch all the lectures in Canvas. You go to Canvas and then Media Gallery. All the lectures should be there. So just want to make sure that I'm clear about this. If you go to our course Canvas and go to Media Gallery, all the lectures except lecture 1 are going to be up there, okay? Lecture 1, we didn't have a Canvas for the course yet, which was a bit frustrating. I wonder if the playlist, I guess, only has 1, but if you click 3 media, it'll have lecture 2, 3, and 4, okay? So if you have missed some previous lectures, it would be helpful to catch up through that. But also the STEPIC textbook is a helpful resource. Okay, are there any questions just about logistics of the class? Deadlines, STEPIC textbook, anything like that? Awesome. Okay, so today we're going to wrap up the experimental code changes part of last lecture, and then we'll move on to talking about how to use the IDE-based debugger, okay? So last lecture, just to remind everybody, we sort of worked on this sidebar.py file in idlib. And specifically, we looked for, we talked about changing this prompt, right? We changed the prompt from having the 3 arrows to being something that can now be like 10 characters long, 12 characters long, and then we also talked about code quality, right? But I just want to reiterate, the reason we talked about this prompt is for the purpose of like understanding the changes that we're making, okay? We specifically wanted to do like, make a small change to this, so let's just say it changes to a smiley face with a couple arrows. And the goal is that when we just run idlelib now, so when we do .python.exe-m idlelib, it'll pop up with the change, right? So the takeaway from doing this is just supposed to be that when we make a small experimental code change to some part of the code base, and then run the actual code base, we should see our changes, right? That just lets us know that this is the actual part of the code base that impacts this part of the application, okay? We're trying to like connect locations in the code base to specific features or specific like functionality in the code base, right? So that's one type of an experimental code change, okay? That was modifying the source code to confirm the purpose of code, right? We were sort of able to figure out, you know, if you remember, we did this global search of 3 arrows, and there were kind of a lot of places where it seems like the Python shell or the Python prompt could be set, right? But by making the change to the specific spot that we did and then actually testing the changes, we were able to confirm that this like shell.sidebar class is where the Python prompt is set. But then there's another type of experimental code change, okay? That's going to be printing or logging to track variable values and updates, okay? So what I mean by logging is most of these like applications or large code bases that you'll be working with will have something called a log that is like maintained alongside whatever application you're working on, okay? And a really helpful way to, what's written up here, track variable values and updates is to write information to a log and then open up that log and just see what information was written, okay? So think of it like, I think a common debugging technique that y'all have used in previous computer science classes, let's say starting from like CSE 8A, CSE 11 or 12, maybe even 30, some like a very common technique that's used is just printing out values, right? Say you're kind of confused about what the value of x is in a for loop. You have like 4x in a list. You'll just print out the value of x, and then you can actually see in the console, okay, first x was this, then x was this, then x was this, right? And that's a very helpful way to sort of keep track what the different variable values are, right? And as long as we don't have like the x being printed out a million times, it's pretty helpful, right? Because maybe there'll be just like 5 or 6 values of x printed out, and we're able to specifically know like, okay, on the first iteration, second iteration, third iteration. In a large code base, sometimes code is going to be hit like multiple times. And so if we have like a print inside of a while loop or inside of a for loop, like the sort of like console can be very crowded, and it can be very difficult for us to track down like, okay, I see the value like 80 printed out in the console, but what was the actual thing that was tied to this 80? And maybe with like clever print statements you can track that down. But what we're going to go over today, the debugger, is going to be a very helpful way to sort of get around this issue of printing. But we'll talk about that in a little bit. First, I want to show you an example of what logging looks like, just so you're sort of familiar with what I mean by this, okay? So just for a bit of context here, there's this website called compassx.ucsd.edu/compassx, okay? This is, you don't have to go to this. This was an early research project when I was at UCSD. We sort of created this tool to help students answer multiple choice questions about coding, but also use like metacognitive skills like planning out their studying, about like self-reflecting, self-evaluating their quizzing. Basically, we would create these like customized quizzes, okay? That's besides the point here. But interestingly enough, this is like maybe like a somewhat large code base that I had worked on previously, and it's part of this, like you can see that it's compassx.ucsd.edu. We sort of got server space from the Jacob School of Engineering, and now this is sort of like constantly running 24/7 on a specific server that we have access to, okay? The reason I wanted to show this actually is because we have implemented logging on this website, and I just sort of want to show you what it's like when I used to be working on this and we would, get some error that a student ran into. This is like some web application, right? And so if we want to see like the specific error that a student ran into, we would have to open this log. So there's some background steps that I had to do to like SSH into this and type in a password, and you eventually have to know where this error log is. But let me just show you what is sort of like written on this log, okay? It's this like really massive, basically text file where things are constantly being printed to it, okay? And so a lot of this stuff, like I don't really know what all that means. And this is like a normal part of a log file. There's probably like in a large code base, there's probably like a bunch of different modules, different parts of the code base that are printing things to a log. It might just be like a success message, like successfully obtained user with ID 12 or something like that. You might want to like have these different print statements or log statements so that you can just track different things, okay? And so here, let's see if we can find, I wonder if there was ever an error that happened recently. Okay, there's some of these WSGI errors, which I think are not actually fatal. Okay, I was hoping to see like if there was an actual error. So I don't work on this project anymore, but whenever there is like an actual error, there will be just a normal Python error up here. It'll have like, I think it'll have the timestamp as well, so you can sort of see what is happening. And I think here, we can actually just look at the date. So Tuesday, April 16th, 3:44. This was just now when I just opened compassx.ucsd.edu. I won't open up the code base and show you, but basically we have a print statement that just prints out the user ID of whoever logged into compassx, okay? So what, like, you can imagine what we would be able to do is say there is some error that happens, later on. We can even track back to like who was the user that did this and maybe like get more information from that, okay? So this admittedly is unrelated to the class in terms of the actual content, but the goal of this is just for you to see what a logging system is like and kind of what the output looks like and maybe the sort of way that you have to parse through it, okay? There's gonna be a lot of things that are just in this log file, but with some like specific or like helpful logging statements, you wanna maybe like print out specific things to the log, just like what we are doing over here. You can sort of see different values of variables, okay? Just like how we're able to see the user ID here. The reason I had to show this instead of something related to idle is because we don't have any similar log that is maintained in idle. There's not, some constant server that's running where we can just access some, text file that is showing all like some specific messages like we have here. And so that's why I sort of showed this. But are there any questions just about what logging looks like? And keep in mind, this is similar to the process of printing, so hopefully the concept isn't totally foreign, but the idea is just in a large code base, we'll typically have some of these logs, and that'll be how you can track down the things that you're basically printing. Are there any questions just about what we just saw with logging? Okay, cool. So let's move on now to printing, okay? So this is something that I think a lot of y'all are much more comfortable with. You'll be very tempted to just include a print statement somewhere. Sorry, this is the class website. You'll be very tempted to include like a print statement somewhere just so that we can see the value of different variables, okay? So let's go back to the example that we were doing last class, right? And I'll just give everybody a second to be on the same page here. You might recall we were working on this update sidebar function that's in sidebar.py. I think it's around line 460. And we were trying to understand like this prompt thing. This thing used to be, the 3 arrows, but we eventually changed it to self.prompt because we created a variable called self.prompt up here, right? And so, one thing that, like say we were just tasked with improving this like Python prompt process, okay? Maybe we had to like make some changes to the base sidebar class, and we just want to understand what exactly is happening in this code, right? So this code is, it has like maybe several different lines. We are not fully sure what each thing does. One thing that seems potentially that seems useful here is like this line prompts, okay? So it looks like whatever we are setting as the prompt, remember we have this prompt and there's a couple different if statements. It's like if console is in something, we're gonna have it equal to, the arrows and the smiley face. Otherwise we'll have like ... and maybe just I can show this process. So right now we have like, the arrows. This is the actual first line here, line 479. We can trigger the ... to come up if we have something like for I in range like 5. And then when I press enter, we have ... right? Because it's still expecting more code to happen like underneath whatever we typed out, okay? And then if we do like print I, it'll do ... a couple more times, then it'll print out everything. There will be nothing here, no dots or no arrows. Presumably that's this none thing because maybe the two ifs weren't actually hit. But then again, we see this prompt, right? And so it seems like if we just like read through the code, so like a good starting point before we start using a lot of these different program comprehension techniques is doing a quick scan of the code. And it looks like prompt is being stored in line prompts, okay? And so say we actually wanted to understand this line prompts thing more, maybe see what the value of it is at different points in the code. One reasonable approach is to print line prompts, right? And y'all can even do this in your own idlib as well, just to sort of follow along and be sort of engaged in this example. But say we add this print line prompts, right? And this is going to be outside of the while loop. We could do it inside of the while loop. Maybe from past experience, we know that if we print something out in a while loop, there's a chance we just like duplicate the print. So maybe we'll just try it outside of the while loop to start, okay? And then, like this is a very reasonable approach, right? We're gonna print out some variable of interest, and then let's actually just run the code and see what is happening, okay? So hopefully, let me just close this. Okay, so we added this print that is on the same sort of like indent level as the while loop, and then let's just run this, okay? So when we go back and look at this, we see some interesting output, right? Also, is this big enough for everybody to see in the back? Are y'all able to see? Okay, cool. So what we saw is we have like 4 empty brackets, and then we have 3 with what is eventually our Python prompt, right? And then let's just press enter, okay? I just pressed enter once, and let's go back and see what happens. Here's some really kind of like counterintuitive output, right? All I did was press enter once to go from, I guess, like a 3rd line to a 4th line. And let me just explain that part real quick. The reason we can sort of make that deduction that we went from a 3rd line to a 4th line is maybe this starts at like 0, index 0 is this first line. Maybe then this is index 2. This is, sorry, index 0, index 1, index 2, and then maybe index 3. It could also be actually just that this is all 1 line, this is all counted as 1, this is 2, and maybe this is 3. That's just maybe a deduction that we're making, right? But we went from, whoa, this is crazy. We just went from 1 to, went from line 3 to line 4, and interestingly, like at 4, initially there was ... but we never saw that ... right? All that happened was we went from the arrows to the next arrow. And then line prompts is back to what it was before. And then it printed this out like, I don't know, 7 more times, right? So one thing this does help us with is tracking line prompts, right? We now have gained like some understanding. We don't really know what's happening under the hood, right? Like why is it actually changing to this 4 ... and then going back to not having the 4 and then having the 4 with the correct thing? We don't know why that is happening, but we do know, I guess, that it happens, right? We know that there's something more there to probably explore, but we are somewhat limited in finding out like why this actually happens, right? So this example is kind of like for two reasons. One is to show that, okay, we can print things out, and this is pretty helpful, right? We're able to see values of variables, and you can imagine in other instances, like maybe we just want to print out, like prompt here, and maybe that will be a little bit more useful. Let's actually just try this. Let's comment this out, and let's just run this again. I'm gonna press enter a couple times. Interesting. So I just press enter a couple times, and you can see we have a bunch of nones that initially happen, and we have these arrows, none, arrow, then 3 more dots. So the point of this is not to say that printing is like a bad practice or anything. I actually think it can be quite useful and quite helpful to just see the values of variables, okay? The reason I sort of chose this example is to kind of also show you the limitations of printing, okay? We actually have like very little idea, like this output is confusing, okay? It's very confusing to me. Like why are all these nones happening? Why do we even see the dots when there were never any dots there? So just maybe let's leave it there kind of on the sort of cliffhanger, I guess, of like printing is helpful for showing us variable values and updates, but it's definitely limited in telling us like what is causing this output, okay? And so that's what we kind of have here as the arrow that like motivates the use of a debugger. The debugger is going to be a very helpful way, and I'll sort of show the demo, that we can actually step like line by line and see exactly why line prompts is shifting from this like 3 arrows, then having a dot, 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 and then removing the dot, 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 and having the correct Python prompt, okay? But I do just want to reiterate the point. Printing is definitely good and helpful, so you should use it as a program comprehension technique, but just understand its limitations, okay? Are there any questions just on this demo or questions about printing or logging here that people might have? Okay, awesome. And we are fortunate in the case that for idlib, when we're doing the development, the output is just in our terminal. I think depending on the code base and where, like how the code base is hosted, like on a server or something, it's not always going to be so simple to just see the output on your terminal, okay? So I just want to be clear, this is an affordance of this code base. It's also, a slightly smaller code base, and we are hosting it locally. This option is not always going to be available to you, okay? Printing something out in a terminal and just immediately running it and seeing the output, okay? Something like logging will likely be available to you, which is very similar to this process of printing. So that's also why I wanted to show you the log file earlier, just so you have an idea of what it is. But just keep that in mind, that this is going to be maybe useful for this code base, but it might not always be an option available to you in whatever internship or job you end up doing. Awesome. Okay, so let's move on to the content for today. We are going to be exploring a new sort of idlib code base feature. And so what I want to do is just run idlib -m idlib and just sort of make sure you are able to follow this, because you'll have to use the same feature. And also, just to make sure, I'll try to make this announcement every lecture. Oh, actually, let me remove these print statements because it's very annoying. Okay, and let's rerun this. So remember that wherever you have built your Python executable, it should be looking very similar to this. When you set your interpreter, you should set the interpreter as the location of the Python executable in your individual projects folder, okay? So I think yours should be 3.12.0 A6. It might be A7, whichever one it is, it's fine. It should just be whatever you clone from the GitHub repository and then built, okay? If you're not using this as your Python interpreter, if you're using maybe something else that was already existing on your computer, like for example, I have all these different versions of Python, right? if I was using like 3.11.1, so I'm gonna just do that right now, okay? You can tell what the interpreter is if you have to have like a Python file open, okay? And then it'll show you the interpreter down here. If I had something like the to-do open, which is a text file, you aren't able to see that option, okay? So just make sure you click on a Python file and then select the correct interpreter. Let me just show you what happens. I don't think it works when you do like .python/exe-m idle lib. Oh, it did work. Okay, that's weird. Maybe it is fine. Hold on. I think if you do like python 3-m idle lib, this will show the old version. I guess what we're doing when we're doing ./python.exe actually just makes sense. We are using the executable that we built, which is Python 3.12.0a6 to run idle lib. But if you do something like Python 3, this is going to be just like the version of Python 3 on your computer, okay? So the point of this is just to emphasize to have the correct interpreter over here, because when we do the debugger today, you're gonna actually need this. But also to actually run idle lib, just make sure you're doing ./python. If you're on a Mac, you have to do .exe, then -m idle lib, okay? So the feature I wanted to show is this. So when you open idle like through this method, through -m idle lib, it'll open the Python shell, okay? We're gonna do file, new file, and now what this has done is open a Python editor, okay? This is not the shell. To be clear, the Python shell is sort of like the interactive window where you can type out these like one-off commands and they'll tell you the output. What we wanted to do is open the editor, okay? And then I'm gonna show you this. So go to options and click show line numbers, okay? Under option, it should say show line numbers. There's also hide line numbers, but we'll do show line numbers, okay? And then one thing I want you to pay attention to is as I go through this, when I go from 9, okay, then to 10, you see how the width of the sidebar changes, okay? When we have something that we're just from 1 to 9, it looks like, you know, everything is sort of, I guess, centered, right? The width is just one character. And then when we press enter to go from 9 to 10, we suddenly go to maybe like a 2-character width in the sidebar, okay? And then I'll just maybe like emphasize this point again as well. So let's just do this, maybe get to 100. Okay, so yeah, perfect. Again, when we're just at 99, let me make this bigger. When we're at 99, it looks like the width of that sidebar is 2, okay? But then when we go one more to like a 3-digit number, we're at 100, okay?
What if we scrolled up?
If we scrolled up, oh, good question. So it looks like the width of the sidebar when we scroll up stays at 3, right? Because we can see the space before the 10th digit. But I thought what the question might have been is then when we delete the 100, we do go back to 2, okay? So that's just the feature I wanted to show. Now, for the first activity, just use the program technique, comprehension techniques that we've already sort of talked about, okay? Try using code navigation. You can make experimental code changes. We have some questions here for you to answer about update sidebar text, okay? So let me just show you how to get to that. And here you can maybe use some of the code navigation techniques. Like we know the name of the function is update sidebar text. So I'm just gonna do Command T, okay? Command T is go to symbol. It'll just open up the hashtag in the top here. And then I'm just gonna do update sidebar text, right? And then it'll just be the second thing. I'll press enter on it and it'll take me to the function. It looks like it's inside. We can use the breadcrumb feature here. We can see that we're in sidebar.py. We're in the class line numbers, and we're specifically in the function update sidebar text. And I just want to be very sort of intentional here and I'll try to like verbalize the thought process. Might also be helpful to take a look at the outline and just see what other things exist in this sidebar.py file. Looks like there's a few classes here. That's what this orange thing indicates. They're classes. Looks like there's a base sidebar class, end line delegator, line numbers, which is where we're at right now. There's also shell sidebar, which I think we worked on earlier with looking at the line prompts and the update sidebar that was in shell sidebar. But right now we're at update sidebar text. So take a look at this code, use some of the code navigation techniques, and try to answer these questions as best as you can, okay? There's a bit.ly here in the next slide. Lecture 5, participation 1. Just take some time to work on this on your own and try to answer these questions. And one more clarification, this is specifically when we go from line 9 to line 10, okay? Like, we want a specific number, a specific value when we go from one to the next. We go from line 9 to line 10. And if you're trying to like run idle lib and you're running into issues, you can raise your hand. We'll try to help you as best as we can. We'll be walking around. But let's see once we get there.
No, I think it automatically. No, I got that like in.
Oh, wait, but
Like here it's set. This is it is like the interpreter. This is telling us what is So I think what it's doing is it's just going to the recommended.
I mean, did both of them always get approved by Google?
But this is telling you what it
I told him that yours was like.
and so we're here. I don't know you would see.
I'm in.
Like if you
I've been done wrong.
Yeah.
So you're doing 18.
Yes, I got.
I think it's that guy was.
Yeah, okay. Yes, and then you can also just test it and make sure you're not cheating, but
Somebody
not
else.
sure that it's just that. Yeah, I tried that. Okay, awesome.
Could be somebody that. He also
What's service list?
Yeah, it's like
Oh, that wasn't you.
I know species or like lines or.
Oh. What? Only a little beyond.
Oh, that's the right.
Look, I'm gonna do something with that tutor tuition.
And we should use your laptop.
And here's what we could do, we could do like a.
As long as you check that.
Yeah, I have the account, so what we could do is actually go outside and see if
That would be kind of funny.
That's an idea. Okay.
You had one really long.
Okay, let's just do like a raise of hands right now. How many of y'all have gotten the value of n and self.prevent? You've gotten that one? Okay. Okay, that's very few, so let's just give it a little bit more time to work on it. Try to get, maybe the first 3. It's okay if you don't get. I'll give y'all like 3 to 5 more minutes, but by the end of that, you just say like no answer or something for the last ones that you don't get. Okay? These aren't for correctness, it's just for completion. And remember, we're looking for specific values, specific numbers, or at least the first one and the third one, and even the fourth one.
No, but the thing is that you need some ways of code from the image.
True.
How is that gonna work?
Is fancy. This.
Not fancy.
I am also.
No, it should really verify.
Well, I think the cursor is on fire, courtesy of appearance.
Oh, actually.
Yes, on fire.
I don't know
Like
that.
that.
I know, I said
It is on fire.
those are fun concepts. Bro, you never even knew. I grow I need to watch this.
Okay, let's start wrapping it up now. So wherever you're at, just write out maybe your final answer if you think you have one. For the remaining ones that you don't get to, just put I didn't get to it. Just like as a spoiler, we're gonna show you how to use the debugger, and then you're gonna just redo the questions using the debugger, and you're actually just gonna modify the form. Okay. So for now, just type in whatever you have, and then if you didn't get to it, you can just put NA or something. Yeah, you can submit, and then I think I have the option where enable where it does email you your response, and then you can also modify your response. Let me know if that's not the case. Okay, cool. So yeah, go ahead and submit too. You can go ahead and submit just to make sure. Remember, this is how you get your lecture participation credit. So make sure you submit something, but then don't worry if you don't get everything. Okay, let's get those responses in. Let me just see. Okay, we have 39, so there's probably just a few of you that haven't submitted yet. I think there's more than 39 people here. Okay, 42. Awesome. Okay, perfect. Let's go over this a bit. We won't have the group discussion for this part. We'll save that for the next activity. But let's just try to get through a couple of these using maybe the traditional methods, like what we've learned so far. So what is the value of end and self.prevent, but also let me know how you kind of got to this answer. So does anybody want to share what they got for the first one? Is anyone able to get an answer? Yeah, in the back there.
I got the value of end was the number of lines inside the file, so it's like at the very bottom whatever that line number was. Self.previous end would be like, okay, so you have 5 lines and you click enter, it would remain 5 while end is 6, but then it gets immediately updated right after.
It gets immediately emptied right after.
Or not emptied, not emptied, but updated to be the same as end.
Okay, awesome. And how did you sort of, so also just a reminder, if you can try to put this in the context of going from 9 lines to 10 lines, the interesting part here is how does this sidebar text expand from 1 to 2? But can you share how you got that answer?
Yeah, I added a print statement at the beginning of the update sidebar text function.
Okay, you had a print statement here, and where was the print statement?
Right after this one. So I do enter and then.
Oh, yes, this, and then you printed out both of them?
Yeah.
Okay, cool. Print and self.prev and. Okay, awesome. And then when you ran this, what is it just, here, let's just actually try running it. So I'll save it, I'll close the previous instance of running idlib, and then let's just try it. So when we go file, new file, show line numbers. So when we go from 1 to 2, yeah, it looks like 1, 1, then 2, 1, and then when we go from 2 to 3, looks like 3, 2. Yeah, so end and prevent is just exactly what we got for the answer there. What is the type of self.sidebar text? Anyone get that? Yeah.
I got tkinter.text.
tkinter.text, okay. First, how did you get that?
So I used the type method in Python by having a print type and then self-sidebar.
Oh, interesting, okay. Yeah, let's try that. Let's do print type self what was it? Sidebar text. Okay, interesting. Let's just see what it prints out. So let's close the previous run of it. Let's do this one more time. New file. Show line numbers. I'm going to do this a couple of times. Yeah, class tkinter.text. I'll just show one other approach we could have used. You can actually just do the control click, so which I think is the same as like go to definition. Okay. Sorry, command click on a Mac. It might be control click on a Windows, but I'll do that command click right now to sidebar text. And what it takes us to is actually like the initial variable declaration of it, but it looks like we have a constructor here, which is tk.text. Then you can actually command click on that, and you get taken to this init.py file. But you'll actually notice, this is again where breadcrumbs is quite helpful. We are no longer in the idle lib directory, okay? We're in something under lib and then something called tkinter, okay? Tkinter is going to be a very, something that we're going to be exploring a bit. It's kind of like a very important part of how the whole idle lib kind of functions. But yeah, you can sort of do this control click into it and you can see maybe a comment, text widget, which can display text in various forms, okay? Maybe we'll just leave it at there at like a high level thing, but this is a pretty, honestly, a good like abstract definition of what a text or tkinter text class is, okay? I won't give too much away, but this is going to be quite important for future projects. Let's just leave it at that. So yeah, but there's a couple ways to do it. You could print out the type. You can also use some of the code navigation techniques. It might also be worth it to, once you click on the class, you can see what the different, parameters are for the init. It looks like there's some, I don't know, maybe these are the standard options basically, and that might correlate with what some of the parameters were that we passed in here. But okay, how about the value of new text? Was anybody able to get this? The value of new text when we go from 9 to 10. Yeah.
I thought it was a new line character.
Yeah, new line character and then 10, and then can you just let me know how you got that?
Oh, I just printed new text.
Printed new text. Okay. Okay, awesome. So I won't demonstrate that, but yeah, it looks like these first 3 we can get from printing. How about this one? Did anybody get the number of times that this was executed? Yeah, in the back.
I got once.
Once? Okay. How did you get that?
I put like a count equals 0 before, before that. And then inside that function, I put count plus equals 1 and then print count.
Okay. Okay. So, interesting approach. Yeah, and so then did it only print out count equals 1 and it never printed out 2, basically?
Yeah.
Okay, cool. So, yeah, that I think makes sense. The interesting thing though is that this is only going to technically be done like if we proceed from this, okay? So think of it as like a while loop, okay? When we have a while loop and then we have like something printing underneath, the question is like how many times is just the while condition checked? And so even if something is printed like one time inside the while loop, we would actually kind of be evaluating the condition twice, right? Once it'll be evaluated true to get into the while loop, but then after we'll have had to evaluate it at some point, it'll be evaluated to false, and then we would jump to after the while loop, okay? But this is a very interesting approach. I didn't think about this, I guess. I didn't do this activity without the debugger, but this would be a good way to get the right answer of 2, which is the right answer, but we'll sort of go to it. Yeah?
Sorry, what does the with keyword mean?
That's a great question. with keywords, so let's actually just Google it. So I think this will be a callback. Oh, context manager. Okay. So we're going to cover this in a couple lectures from now. We're going to have a lecture on something called just-in-time learning. So the idea is when you encounter something that you haven't really encountered before in a code base, which will definitely happen, whether it's a language feature or something like this, we're going to have to take some steps to Google it and try to figure it out. So what I just did was control click on it. Let me just go back. I did a command click on it, and then we see this context lib context manager, okay? So a context manager is kind of like, if you've ever worked with like databases before and had something like a lock that you can put on a database, then you'll unlock it, make some changes, and then lock it again. That's kind of what the with keyword does, or that's really what a context manager does in Python. It'll have this like try finally sort of structure, where the first time we encounter it, we do whatever is in the try, and then later when we encounter it, we do whatever is in the finally, okay? And this is actually very relevant to, you can see this like tk.normal, tk.disabled. Maybe you'll have recognized, we saw this tk before in the context of tkinter, right? It looks like it's a wrapper function for tcl, tk, and then it talks about tkinter. At a high level, that's what a context manager is, but I'll go over it more in a future class. But that is a good question, and I encounter this all the time when I don't, when I encounter some syntax or something that I haven't seen before. The best approach is just Googling it or using ChatGPT. Like I would straight up just Google how does the with keyword in Python work? Oops. Yeah, and maybe you'll want to see stuff with an example. So yeah, it looks like it's used with exception handling. That's typically what a try, except, finally is typically used to handle. Like when the code sort of throws an exception, we'll try something. If it throws an exception, we'll maybe catch the exception or have like a finally statement that should just get us out of whatever situation caused the exception, okay? But yeah, this will give you maybe a general sense of like what is the with keyword and how is it used. But then you might want to be exploring in the context of our actual code base, like how is it used here? Like what exactly is this text, what is this text.configure doing? What does yield even mean? What does finally mean? These are questions that are part of the program comprehension process, and we'll definitely cover it because this is obviously a very important part when you come across something you haven't encountered before. How do you sort of approach it? But yeah, that's also where something like the debugger will be quite useful because we'll figure out how to answer these questions. Okay, so let's actually move on to the debugger now. We're not doing great on time, so let's try to get through at least setting up the debugger. Maybe I can show a demo. We might not get to the second activity today, which is fine. So make sure you submit the first one because that might be the only activity we get to. Okay, so the debugger. Let's go back to the slides here. So the debugger, how many of y'all have heard what a debugger is before? Can I see a raise of hands? Okay, keep your hand up if you have been exposed to it in CSE 15L. Is that where most people, okay, that's where everybody is. Have people used it outside of CSE 15L? Can we just crowdsource, has it been something that you've used before? Anybody want to share, what did you have to use it for? Yeah,
I used it in a database intro class where we had a hard time in finding doing a debug tree and having a photo flow.
Okay. Sorry, I just want to see again, how many of y'all have used the debugger outside of CSE 15L? I'm just curious how relevant. Oh, okay, not too many. Some people, maybe 10 to 15. Okay, so our sort of rationale for reteaching the debugger, we know 15L is, oh yeah, question.
When you say debugger, do you mean the terminal?
Yeah, okay, I guess there's a terminal-based debugger, and then there's also an IDE-based debugger. How many of y'all use the IDE-based debugger? Okay, a few, cool. Wait, in 15L, do y'all learn GDB, or is it also the IDE-based debugger? GDB. Oh, you don't learn the IDE IDE-based debugger, if you know? Oh, okay, interesting. Okay, so this is going to be pretty helpful, I think, for everyone then. This is a really powerful tool inside an IDE that, like I was kind of alluding to earlier, helps you step like line by line and actually use the IDE features to get like some really helpful information about the code. Okay. So let me delete this. Before we get started, there's actually just a setup thing that everybody will have to do. So if you can go right now to your idle lib in VS Code. So if you don't already have this open, try to open it. And then we'll go to the project directory. You should have a .vs code. Actually, you might not have this. Go to this run and debug. There is the fourth icon here, which has a little play button and then a little bug in the bottom left. Hopefully you have that. And then I think if you haven't created one yet, there might be like a settings button and it'll say like create launch.json file. You might have to click these three dots. You should select Python debugger module. This is just maybe like a shortcut to create the launch.json file. You also don't have to go through this way. I forget what exactly the shortcut is, but when you're in the idle lib directory, you can just create a new folder. You should create a new folder in idle lib that's like .vs code, and then you can maybe just drag it to the actual idle lib thing. I already have one, so I'm just gonna delete this. But create this .vs code folder that's in the same sort of directory as like one level underneath idle lib. So it should be in the same sort of level in the hierarchy as all the other Python files. You should create this .vs code folder, and then I'm gonna copy paste this code in the actual slides. Ooh, okay, let's do. Yikes, that is tough. Okay, maybe let's just do it like this. Should be transparent. Let's do text color. Let's make this bigger. Text color black. Okay, so one thing I'm worried about. So make sure you copy paste the start and the bottom of the colons. Sorry, yeah, the brackets. Okay, yeah. If you copy paste it, the formatting should be preserved. The one thing I was worried about is sometimes there's an issue with the quotes. It might be using like different type of quotes basically where it doesn't register it in the IDE. But are people able to do this? Are people able to create the .vs code folder and then the launch.json file? Okay. Yeah, I'm gonna give y'all maybe a minute to just get to this point. If there's any questions, I can just re-show it. Remember, go to this slide, and you don't need to do the three, I think I had like 3 quotes at the top and bottom. You don't need to do that. Just do this start colon to this bottom colon, okay? I wonder if there was an easier way to distribute this. Maybe it could have been an extend post with a code block. That probably would have been more useful. But yeah.
I mean, you can just, I'm pretty sure you can Command Shift V and it wouldn't affect any of it.
Yeah, I think I did that, but then it was also very small. Here, let me try that.
Well, now it's gonna.
Oh, okay, awesome. Thank you. I thought I did that earlier, but I didn't. All right, copy paste this. I think it'll be the same process, but thanks for that.
Create a
Yeah, so this is what it should look like. This is honestly like exactly what yours should look like. Under idle lib, you'll probably have a PyCache folder. There will be icons and idle test, but in that same sort of hierarchy, you have a .vs code. And then inside VS Code, you can do new file basically and create something launch.json. Make sure it's spelled correctly with the .json extension. So I'll give everyone a few more seconds. Yeah?
Can you show how you get the launch.json here?
How to get, so you'd have to create this. I do think there's a way if you click Debugger and you haven't configured it before, I think maybe in the settings it'll like create a launch.json file.
Oh yeah, it's there.
Okay, cool. good. So just make sure at the end, like, of this process, your VS Code looks like what you can see on the screen up here, okay? And also, simultaneously, just make sure that your interpreter is also the same as the version that you built, okay? I do have a worry that if it's not 3.12.086, that it won't work, but we'll see. If I had like met with you before class and we talked about using like a different version of Python, then yours can say something different from this. But otherwise, for most of y'all, yeah.
Do we need the Python debugger extension?
I think it's very quick to download, so you can do that. Okay, just download that because I think does it give you the automatic prompt to download the Python debugger extension? Okay, just
I'm trying to download it right now, but it's like, oh.
okay. It might work without that, but anyway.
Just to check, we're opening the VS Code as an item that not the whole VS Code that's installed.
Sorry, I just say that again. You're saying this should be in the idle lib directory.
Yes, we're just opening the idle module.
Yes. Also, like, make sure this isn't. Make sure it says idle lib on the top here, not individual projects and then your, SID or whatever. It should be in the idle lib folder. You might actually have to get the Python debugger extension, but I think it would work without. Okay, let's just do this in case. You can go to the extensions. This is also maybe just a cool piece of information about VS Code. There's extensions that you can install for VS Code. I think in the next couple lectures we'll show you. Charles has a demo of a few helpful extensions that he uses, so this point will maybe be made more clear. But you can go to these extensions and try to download Python Debugger. Okay. You can search the extension and it should be from a trusted source from Microsoft. You might have to close it, like close VS Code and then reopen it, but this should work. Importantly, make sure that just my code is false. But if you copy pasted it, I guess it wouldn't be a problem. Okay, can I just get a raise of hands? Like, how many of y'all have completed this and are pretty, confident that I said it correctly? Okay, most of y'all. Awesome. Okay. So I'll move on now. But again, if this is like an issue, you can come see us after class. Or I think honestly, just do this setup before next class, and it'll be helpful. I think we're only going to get to the actual activity next lecture. I'll just demo the debugger right now. So, okay, so don't worry if you're not able to actually do this on your own, but I'm going to show you now how we can use the debugger to understand part of this update sidebar text, okay? So, let's do update sidebar text. So, there's a couple parts of the process of a debugger, okay? So one thing, make sure that you're sort of in this setting or in this view when you're working on VS Code. It'll be very helpful for tracking what we call breakpoints and tracking different variable values, okay? You see this variables tab here. So what you can do to start is deciding where to set a breakpoint, okay? A breakpoint is going to be basically a marker for where the code should stop running so that you can start examining the code from there, okay? So I'm just going to show an example of setting the breakpoint right here, okay? I'm just going to set the breakpoint at line 341 in sidebar.py, which is where we do the calculation for width difference, okay? Using the subtraction of the length of end and self.previous end, okay? If you're able to, you can, also click the set the debugger or set the breakpoint here and try to follow along, okay?
That's great. That's what the red dot.
Yeah, so that's what the red, if you ever had to like hover your cursor over this thing to the left of the line numbers, you'll see this red dot, and that's what you can click to add a breakpoint, okay? So I'm just gonna set up 341, and then interesting, you can see at the bottom here that you can track the different breakpoints, okay? If I add another breakpoint over here, it'll pop up as sidebar 344 to indicate you set a breakpoint at sidebar 344, okay? So now what I'm gonna do is I'm gonna actually run this. And to run the debugger, we don't run /python in the terminal here, okay? To actually run the debugger, you press this run button that's in the run and debug sort of like option, okay? So under here, run and debug, we'll click the play button, and then you'll see this thing pop up. It'll say some actual command that it's running. Basically running this, pressing this play button executes a specific command for running the debugger, okay? You might see a warning here about seems that frozen modules are being used. It might miss breakpoints, but pass this parameter to disable the frozen modules. You'll notice that that's actually what we had done in launch.json. We had this x frozen modules equals off, okay? So just, if you see that, don't worry, because I think we should have addressed it. So, what happens is it'll open idle as normal, okay? Remember, all I had done before was set the breakpoint and I pressed play. And then it'll open idle. Now I'm gonna do file, new file. All right, I'll do option, show line numbers. Now I'm gonna press enter, okay? And if y'all are able to follow along, please do so. So when I press enter, I just press enter there, and it immediately took me back to VS Code, okay? I didn't swipe my fingers to take me back to VS Code. It'll just, whenever the breakpoint gets hit, it'll automatically, like, it'll either give you like this spinning ball of, like, whatever, the spinning beach ball or whatever, like, on this, it'll just tell you that the application is like suspended right now, okay? The reason the application is suspended is because we had set the breakpoint and paused execution here, okay? That's what the breakpoint does. It stops the execution, and now we have all of these options here, right? We have, and if you hover over it, you can see what they are. We have continue, step over, step into, step out, and then restart and stop, okay? I have a slide here for what these different buttons mean. You can sort of analogize it to like watching TV or watching a movie and having like a control that can pause it or zoom in or zoom out or go to the next frame, okay? So I think of this as this first button is like the play button, okay? When you just play it, it'll just pass over the breakpoint and continue running like normal. So if I just press play, I'll press play at the end actually, let's show the other ones. This like step over button is like moving to the next frame, okay? What you can do, this is like a very powerful one. If you click step over, it'll then like actually execute with difference. Ooh, it's 4:43. Okay, let's wrap this up and then I'll present project 2. We'll get more into the debugger at the start of the next lecture. But let me just wrap this up here. So step over is basically executing one line at a time, okay? And what happens when we execute one line at a time is that we can actually see the values of these different variables, okay? So I stepped over with difference, and now I saw that with difference is equal to 0. Before, it didn't even show up as a number, right? We also can see that end is 2 over here. And we can also expand this self, and we can see all the different attributes that are there in self, and one of them is prev-end, okay? And we see that prev-end is 1, and that can help us determine the values of end and previous end, okay? One very annoying thing though, so let me just press play. I'm gonna press the play button now, and what this is going to do is, now the debugger, like the breakpoint is no longer there, and now I can actually keep controlling this like normal, okay? I can do like new file, all those things. But the annoying thing is that, say I go from 2 to 3, it's gonna trigger the breakpoint again, and so now I'll have to press play again, and then I can finally go back to the debugger. If I press enter again, it goes back to it, right? So one very helpful tip here is selecting the correct breakpoint, right? To make your life easier. The ideal way, like say we wanted to do this next activity to find out all this information, the ideal place to set the breakpoint is to put it under width difference, because this means that there actually was a width difference between self.previousEnd and self.end, right? Because previously the width was 1, and now we have a width difference, so we're going to go to 2. We can see this code here. Let me just do this one and then get to project 2. So if I set the breakpoint here instead of where it was above at 341, and now if I run the debugger, when I do new file options, show line numbers, when I go from 1 to 2, nothing happened, right? The breakpoint didn't get hit because, you know, the fact that the breakpoint didn't get hit even tells us some information about what code is being executed, right? We know that line 343 was never executed just when I pressed that enter right now, right? But if I keep pressing enter and go from 9 to 10, now I can see that the breakpoint, the view gets returned to VS Code. I can see the breakpoint. I can see end. I can see previous end. I can also see width difference is 1 this time, right? Because the width difference between 9 and 10 is 1 character. Then I can step over this. It looks like current width is 1. And then when I execute line 344, new width is going to be equal to 2. Okay? And then you can even step into a function. So what I just did was, say you have like a function call here. There is a function call to like sidebar with type. If I press this down arrow, it'll actually like, oh, whoops, I think maybe because I already pressed it, it didn't go through. When I go to here and do down, it'll like take me into whatever function is on that line, okay? So I'm definitely going to cover the debugger in a lot more detail next lecture. I think we, spent a decent amount of time on the motivating the debugger, but I'm totally okay with that. I think this part of the course is really important for y'all to pick up these program comprehension techniques. So no need to actually do, actually, you know what? We'll make this the exploration activity. Let me think. Okay, never mind. Don't do any exploration activity for this week, for this lecture. We'll have that be part of next lecture. Same with do the reflection form, okay? Remember the reflection form is the second to last one. You'll be able to click this bit.ly here. Do it after the lecture though. Right now I'm going to show you the second project, okay? So just pay attention to this part. So one cool feature, so imagine I'm sort of like the team lead on the idle-live developer team, and y'all are all team members, okay? So as the idle-live company, we have a bunch of competitors, right? One of our competitors is VS Code, right? Because they're also in the space of creating IDEs. So one cool feature I want to show you is this go. When you click go up here, you can do go to line, okay? You can also invoke it with Control G on a Mac. So if I do Control G, it opens up this it has a colon at the top here, and then it tells you the current line, and then it says type a line number between 1 and 780 to navigate to. And say I just type in 101, it takes me to line 101, okay? This is a really awesome feature. If I backspace 1 and I just have 10 entered, it'll automatically take me to line 10, okay? But let's look at the same feature on idle-live, okay? So let me go to this and execute it. So let's do /python.exe-m idle-live. So we've gotten some maybe poor feedback from our users when we say show line numbers and we have this, okay? And we do edit, go to line. This is what our message says. It says enter a positive integer, big equals end of file, okay? This is confusing to our users, especially this big equals end of file thing. Does anyone know what I should do? Say I wanted to go to the end of the file. What would I have to do here?
Type big.
Type in big, right? That's what you would think. That's what this makes it sound like. But it says error not a base 10 integer, right? So actually, you have to do the quotes. But it's still actually a base 10 integer. So it's not, this is a very uninformative prompt, okay? But one really cool part about this is in VS Code is, where was go to line, is that it tells us the current line we're at, and more specifically, it tells us what the maximum is, right? It tells us 780 at the end. So what you're going to do is actually change the go to line feature to modify this message to get rid of the big equals end of file, and you should show, just like what it is in VS Code, you should show like the type of number between 1 and the total number of lines that's currently active in the editor, okay? So for example, in this one, we have